Good afternoon, students. So this is Mr. Chen. Welcome back to my master class. So this one's for pre-calculus and also for trigonometry. So the continuation of section 7.3 from the James Stewart pre-cal. And this one is about the half angle. So let's talk about that, the half angle formulas. So for the half angle formula, we do have the following. So sine of x over 2, so that equals plus minus square root of 1 minus cosine of x over 2. Cosine of x over 2, so that would be plus minus. So square root of 1 plus cosine of x over 2. The reason why that's being considered plus minus, because that it depending on the quadrant of where the half angle is landing, whether that's quadrant 1, quadrant 2, quadrant 3, or quadrant 4. And then for tangent, x over 2, so we do have 1 minus cosine of x over sine of x, or the alternate form, so sine of x over 1 plus cosine of x. Okay, so now we'll look at the following problem. So find the exact values of the following. So sine of 22.5. Okay, so to look at that, sine of 22.5. Okay, so for the first one, so this one can be written as sine of 45 over 2. So using that, the half angle formula, so we do know that sine of the half angle, well, 45 over 2, 22.5, it's in the first quadrant, so it's going to be positive. So square root of 1 minus cosine of 45 degree, all over 2. So what we found here is 1 minus root 2 over 2 divided by 2. Okay? So this one here, if you don't want to deal with the denominator, so you can always rationalize it, the inner rational expression, multiplied by 2 top and the bottom. So we do have 2 minus root 2 over 4. And then radical with another radical, you can always separate it. So square root of 2 minus root 2 all over 2. Okay, so that's for 10a. And now what about for 10b? So cosine of 7 pi over 8. Okay, so cosine of 7 pi over 8. So again, using the half angle identity, so this one is written as cosine of 14 pi over 8 divided by 2. So in other words, like cosine of 7 pi over 4 divided by 2. Okay, so using the half angle identity, so 7 pi over 4, so this one got to be very careful with the quadrant number. So 7 pi over 8, it's in quadrant 2, so it's going to be negative. Square root of 1 plus cosine of 7 pi over 4. And then divided by 2. So cosine of 7 pi over 4, that's 0. So it's negative root 1 over 2, which is negative root 2 over 2. Okay, so again, cosine of 7 pi over 4. Well, let's see. That one is not 0. Okay, let me just go back. So that's just the multiples of pi over 4. So we got 3 pi over 4, 5 pi over 4, 7 pi over 4. So that's going to be root 2 over 2. So it's negative 1 plus root 2 over 2 over 2. So for this one here, again, don't want to deal with the rational fraction with another fraction. Rationalize it. So multiply by 2 top and the bottom. So 2 plus root 2 over 4. Separate it out. So we got negative 2 plus root 2 all over 2. Okay, so now let's see what else. And then for C and D. Okay, so let me take this one to a new page. Okay, so now for C and D. So it's a positive square root of 1 plus cosine of 16 theta over 2. So in other words, this one is written as, if you try to condense it, so this one it's the half angles of cosine. So it's cosine of, okay, let's see, 16 pi over 2. Or 16 theta over 2. So this one is the same as cosine of a theta. Oops. So cosine of a theta. Because once you rewrite it, so this one is considered cosine of 16 theta over 2. Using the half angle identity. And then what about this one? So this one, try to use that the tangent. So it's 1 minus cosine of 2x over sine of 2x. So in other words, it's like tangent of 2x over 2, which is the same as tangent of x. And also you can verify that by using the double angle identity. So 1 minus cosine of 2x is like 1 minus, let's see. Yeah, I can always verify that by using the double angle identity. So rewrite it in terms of sine. So it's consider 1 minus 2 sine square of x. And then the other one, sine of 2x. So 2 sine x, cosine x. 1 minus 1 got cancelled, so we got negative 2. Positive 2, because that you want to distribute the sine. 2 sine square of x over 2 sine x, cosine x. And then reduce. So sine x over cosine x, tangent of x. Okay, so now let's see what else that we have for the half angles. For the half angle formulas. So find the value of sine of x over 2, cosine of x over 2, tangent of x over 2 with the given conditions. So this one is quite similar to what we did in trig. Okay, we'll do one of those. Okay, so this one is given as cosine of x equals negative 3 over 5. So first thing that you want to do, you want to draw the diagram. So this one, it's 180 to 270. So that means x is bounded in quadrant 3. So negative 3 over 5, so adjacent over hypotenuse, opposite is negative 4. So sine of x over 2, so using the formula. So half angles, so divided by 2. So that means the half angle, it's right in quadrant 2. Okay, so quadrant 2 back here. So sine, positive. So square root. And it's 1 minus cosine of x over 2. So square root of 1 minus cosine of x, which is negative 3 over 5. And then all over 2. So combine them. So we do have a over 5 divided by 2. So it's a over 10. So take the square root. Before you take the square root, reduce it. So it's 4/5. So 2 over root 5. So 2 root 5 over 5. Okay, so reduce it. 4/5. 2 over root 5. So 2 root 5 over 5. And then what about for cosine of the half angle? So that's in quadrant 2. So that means it's negative. So square root of 1 plus cosine of x all over 2. So negative square root of 1 plus negative root 3 over negative 3 over 5 all over 2. So it's 2/5. So negative 2/5 over 2, which is 2 over 10, 1/5. So negative root 5 over 5. And then for tangent, so this one is written as 1 minus cosine of x over sine of x. So 1 minus cosine of x, which is negative 3 over 5. So plus 3 over 5 over sine of x, negative 4/5. So we got a over 5 divided by negative 4/5 multiplied by the reciprocal. So negative 2. Okay, so B, that's something quite similar to the one that we just did, but this one is in quadrant 4. So think about 11B. And now let's see what else that we have on the template. So using the triangle to find the value of cosine of theta over 2. Okay, so that one's relatively easy. So this one, cosine of theta over 2. So using that to have angle identity. So plus minus, so this one's positive. So 1 plus cosine of theta over 2. So we got cosine of theta, which is 5 over 8 divided by 2. So 1 plus 5 over 8. So then that'd be 13 root 13 over 8 divided by 2, or multiplied by 1/2. So we got root 13 over 16, which is root 13 over 4. And this one might be considered brand new stuff. Use the power reducing identity to write that sine of x to the 4th power in terms of the first power of cosine only. So multiple angles are okay. Okay, so let's talk about the power reducing identity. So for the power reducing identity, we do have the following. Okay, so let's take a look at that. So sine square of x is considered 1 minus cosine of 2x over 2. And then cosine square of x, so that equals 1 plus cosine of 2x over 2. So it's quite similar to the half angle identity. So the difference is that without the plus minus, without the radical, and that instead of using cosine of x, cosine of x, cosine of x, so it's all written in terms of cosine of 2x. And then for tangent of 2x, it's just 1 minus cosine of 2x over 1 plus cosine of 2x. Okay, so using the following identity, so we're going to find out the rest of the solution right here for this page. Okay, going back. So use the power reducing identity to write that sine of x to the 4th power. So this one can be written as sine square of x times sine square of x, or quantity square. So basically this one is written as 1 minus cosine of 2x over 2, and then quantity square. With the first power, okay, with the first power, so that means the other one. Okay, so keep it this way first. And then rewrite it, so this one's 1, expand it, minus 2 cosine of 2x plus cosine square of 2x. So it's all over 4. So what I did here, I just squared that top and the bottom. And then cosine square of 2x. So that one can be written with, okay, let's put it this way. So that one can be written with 1 plus cosine of 4x. Because that's square, 2 times 2, so 4x over 2. So it's 1 minus 2 cosine of 2x plus 1 plus cosine of 4x over 2, and then all over 4. And obviously you can simplify it a little bit more. Okay, multiply by 2, top and the bottom, so we do have 2 minus 4 cosine of 2x plus 1 plus cosine of 4x, all over 8. Okay, so then that'd be the simplest form. And then 14 and 15, so let's find out. So let's put it right here. So it looks like we need to use like substitution for that one. So 14 and 15. Okay, so 14, it's 1 minus m squared all over 1 minus n squared. Okay, so let's just plug in those value. So what we found there, it's 1 minus cosine square of 11 pi over 12. All over 1 minus cosine of 5 pi over 12 square. So this one, 1 minus cosine square, just like sine square of 11 pi over 12. Using the Pythagorean identity, sine square of 5 pi over 12. Oh, perhaps we can just rewrite one of those. Okay, let's just keep it this way first. So sine squared using the power reducing formula. So we do have 1 minus cosine of 2 times 11 pi over 12 all over 2, then divided by 1 minus cosine of 2 times 5 pi over 12 all over 2. As you can see that the 2 and the 2 will get cancelled. So 1 minus cosine of 2 times 11 pi over 12, then that would be 11 pi over 6. And then 2 times 5 pi over 12, then that would be 5 pi over 6. So 5 pi over 6, which is cosine of 30 degrees in quadrant 2. So then that would be negative root 3 over 2. 11 pi over 6. Then that would be in quadrant 4, positive, so it's root 3 over 2. So we got 1 minus root 3 over 2, all over 1 plus root 3 over 2. Multiply by 2 top and the bottom first, so we got 2 minus root 3, and then all over 2 plus root 3. And then rationalize it. Multiply top and the bottom by 2 minus root 3. So we do end up with 2 minus 3, which is negative 1. And then numerator, expand it. So 4 minus 2 root 3 times 2, 4 root 3. And then plus 3. So the top part right there, we got 7 minus 4 root 3 over negative 1. So it's negative 7 plus 4 root 3. Okay, so using that, the power reducing formula. And now what about for number 15? Number 15 is quite similar. Okay, so number 15. So let me just clear all the annotation. So 15, so we started off with cosine to the 4th power, 5 pi over 12. Minus sine square of, well, sine to the 4th power, excuse me, 5 pi over 12. And then this one can use the difference of 2 squares, so cosine square of 5 pi over 12 minus sine square of 5 pi over 12 times cosine square of 5 pi over 12 plus sine square of 5 pi over 12. Well, obviously this one is the Pythagorean identity, that's 1. And this one here, what do you think that is? Cosine square minus sine square, so the double angle, so cosine of 2 times 5 pi over 12. So instead of using the half angle or the power reducing formula, we can use that the identity, the double angle, and the Pythagorean identity. So this one is just cosine of 2 times 5 pi over 12, which is 5 pi over 6. So quadrant 2, 5 pi over 6, so cosine of 30 degrees in quadrant 2, which is what? Negative root 3 over 2. Okay, and that's it. And then the rest of this, product to sum to product identity. So we'll get to those in the next video. Okay, so stay tuned. So thank you for watching the lesson today, and I'll see you guys next time. Okay, you have a great one. Take care. Bye.